The next macromolecule that we're going to discuss would be lipids, and lipids are very important. Lipids also are the one macromolecule that don't really fit our normal group because they are not polymers. Lipids are the only ones that are not polymers, and the reason for this is that a polymer has to be made up of many objects bonded together. So a lot of the times it's in a chain, and that chain can become three-dimensional like we saw, and it has the objects on it. But it's a lot of them, many, many, many bonded together. We'll see a picture of a lipid in just a little while. But most lipids don't look like that. Many of our lipids have one chemical, it's kind of oblong, with three attached to it, and that's it. They don't form a chain where they bond together over and over again. So lipids are not considered polymers, but they are macromolecules as they are large molecules. They are insoluble, meaning that we can't dissolve them in water. If you've ever tried, it doesn't work. Italian salad dressings and things like that work because the fat part doesn't dissolve, so you have to shake everything up so you can see the lipid layer versus the water layer. The elements very similar to carbohydrates. You have the carbon, hydrogen, and oxygen. And some examples would be fats. When you hear the word fat, you're talking about a lipid. When you hear phospholipids or steroids, those all fit into the lipid category. Now, if we take a look at fats, you may have heard about glycerol or fatty acids. Those words you'll hear multiple times when we're talking about fat. They are made, this is what the two types of monomers we really think of. They don't have one specific monomer that repeats. That's why they're not polymers. But they are made up of glycerol, that's kind of the oblong rectangular one. And then the fatty acid chain, which you can see here, there's three of those. And that's kind of it. You have the four pieces there. It doesn't repeat itself. Triglycerides are a very common type of fat. Triglycerides have three of these fatty acid chains that I have circled there. That's where the triglyceride name comes from. And you can see it here color-coded in green, the glycerol, and then the three fatty acid chains to make the triglyceride. You may have also heard of saturated fat. If you've ever looked at any food labels, they will kind of divide the amount of fat into saturated, unsaturated, trans fat, things like that. So saturated fat just means that chemical-wise there are no double bonds between the carbons. So carbon to carbon, if you look at just this inside chain here, carbons bonded to other carbons, you're going to notice single bonds, single all the way across. There are no double bonds in a saturated fat. Unsaturated will be on the next slide, but this picture won't be there, so briefly just take a quick look at it. And if we look at the unsaturated fats, notice that now there is at least one double bond, and it kind of creates this bent shape. This one's very straight across. When you add a double bond in there, it makes the chain bend, and so that would be an unsaturated. Go back to saturated fats though. We're talking about this one right here with all the single bonds. Anything that has animal fat in it would be a saturated fat. So steaks, salmon, eggs, those types of things. Even cheeses, since they do comes from the milk of a cow, or even if it's goat cheese or something, it's still an animal. They're going to be solid at room temperature, and that's because of this straight chain. They can kind of bond on top of each other in nice, flat stacks, so it creates a solid object. Butter, lard, those would also be examples of things that contain saturated fats. Now if we look at unsaturated fats, here's that one or more double bonds. The picture I showed you only had one, but we could have more than one and it would still be unsaturated. Plant and fish fats are all going to be unsaturated. So olive oil comes from a plant. It is unsaturated. Fish oils, most of the time, like the omega-3, people take like a fish oil pill. That's an unsaturated fat. And these are going to be liquids at room temperature, and that's because of that bend shape that you get. They can't stack on top of each other very easily, so they will stay as liquids. And I already mentioned the olive oil. Now, some dangers of fat. probably have heard of heart disease, atherosclerosis. This would be a normal coronary artery, very open so that your blood can flow easily. As you start to eat a lot of fatty foods, then your body has to put that fat somewhere, and your body will create plaque, and that is what this yellowish material is here. Notice it's kind of creating this little hill, and that is decreasing the amount of space that your blood has to flow. And as you get more and more of a blockage there, your blood vessels, not the blood vessels, the blood cells have a hard time traveling in this thinner path. And so you get a clot, could have a heart attack, you could have an aneurysm, you could, stroke, those types of things. So dangers of fat, this is saturated fat is the more dangerous, so that's why people, eating a lot of red meat isn't really considered healthy, and that's because of how much fat it contains. So it's the animal fats, the saturated animal fats, that are really the worst ones for you. Plaque will build up on the walls, like we mentioned. It decreases blood flow. It could completely stop it if the clot is 100%. Now, fat does serve a purpose. It has a job for us, and that is energy. So carbohydrates and fats are similar in the fact that both of them, we rely on both of them for energy. If you take and measure out a gram of fat and a gram of starch, you're going to get twice as much energy from the fat. And so that's important to know. People will ask, well, why don't we just eat more fatty foods and less carbohydrates because they give us more energy? Normally, people don't need to. Honestly, we eat more than we need to anyway. And so if you were to eat more fat and use that for energy and you don't use that up, then you're going to be have some negative health effects. But like we mentioned with the fat, the heart disease, you don't want to be eating so much fat because it can lead to heart disease. So carbohydrates will give you energy, maybe not as much as a fat, but it decreases your chance of the heart disease portion of that. An adipose cell is the cells that are in our human bodies that store fat for us. So this is what that looks like. There's just a very large opening specifically where extra fat goes, and when we're not using it. When you need it, say you go a day without eating, or you're very, very active and you haven't eaten enough to cover those calories, your body will take from these adipose cells and will take from this fat reserve and use that for energy. It also provides a cushion, so you'll have these adipose cells around your vital organs, like your kidneys, to help you so that if you were to take a blow to something, it helps protect your organs. Also insulates your body as well, so it's a warmth. Phospholipids are another type of lipid. These have a very unique look to them. They have what we call a hydrophilic. Hydrophilic is it likes water, it loves water. So that would be this part right here. This part likes to be with water. It will dissolve and it's okay being close to water. But then you have these two tails. So not like a triglyceride that has three. A phospholipid has only two tails with it, and these hate water. They repel it. They're hydrophobic. You don't like something. And when you put them in water, they form a layer because this part likes the water and wants to be close to it. This part with the tails doesn't want to be close to the water, and so you're going to get something that looks like this. The tails are going to point inward. Okay, the water's out here, and the water's in here. And so the heads like the water, the tails don't. So the tails will point toward each other to try and get away from the water, which makes the hydrophilic head point outward. All right, so this is how we form our cell membranes. This is the boundary. So you have all of these little red objects. Those are the hydrophilic heads. You can see the little tails pointing inward, and you get this three-dimensional all the way around. Water on the inside, water on the outside. And this is what your cell membrane looks like. Three-dimensional cell. All your nucleus and all your cell parts would be in here. Another picture. Notice all these hydrophilic heads, the hydrophobic tails. These phospholipids make up the whole outside. You have some other things in there as well, proteins and some cholesterol, carbohydrates, things that attach to the surface, but mainly this whole surface is all phospholipids. So they're an important, major important item for you since you have so many cells. You have a lot of phospholipids. The last slide that we're going to look at here talks about steroids. That was one of our examples. And steroids, we want to look at cholesterol. So cholesterol is a type of steroid. It is also an important part of the cell membrane as well, so it attaches to the outside. Many of the hormones that your body makes come from cholesterol. So your body makes cholesterol, you get cholesterol from the foods that you eat. It takes that and changes them slightly into the hormones that your body might need. Things like estrogen or testosterone. There's all sorts of hormones that your body releases to keep you healthy. These are really important in animals. High levels, though, can contribute to heart disease, so cholesterol in good amounts is all right, but if you have too much of a good thing, it's a bad thing. So you want to be careful with animal fats and also things that are high in cholesterol.